Thank you, Mr. Pat. Thanks, Gerald. Let me just trying to run double duty here. Pop that up a little bit. There we go. All right, so again, I threw this together this afternoon as well, but it was a talk I was planning on giving in a couple of months. Let me just pull up my notes. That's not the right notes app. Thank you. Cool. So this is basically, I've spent a bunch of time playing with Swift macros. This will be a bit of the development workflow that I ended up with, how I iterate, how I actually make this work. Unfortunately, I can't tell you how to deal with the Xcode bugs. I had to drop back to beta 2 to be able to do this because beta 4 just said no. Like every time I save the package.swift file, instant crash. So back to beta 2, and that seems to work okay. Part of this will also be a bit of a complaint about how crazy complex the Swift language actually is to parse and understand. So first up, if you haven't seen the macros presentation, especially the expanding macros one, I think it is, this is the best table or the best reference that you'll find on what all of the different macros are, because unfortunately the Swift docs have lots of long form text but no list that says if you want to do this, this is the macro to use. So that, just a screenshot from the talk, definitely the best table and the best reference that's out there. All right, so fingers crossed this actually works. I'm not sure, you might have seen there's a Aspireable macro package that somebody published a couple of weeks ago. That's actually really good. I was already building something similar, but this has actually turned into a really good way to learn Swift macros and Swift syntax, because Swift syntax is basically the whole problem, I guess, with Swift macros. It's a mildly complex thing. Let me close that. All right, so tip 1, don't try and write your macro code in actual where you're going to use it in your code. It's just too buggy. You don't really get any way to inspect what Xcode has generated or what your macro has generated until the compile errors start coming in, and then you've got to right click and expand macro and then view the things. Best way I found to iterate, set up a unit test for your macro, and I'll just run that. Pop in your basic code that you want to do. Test is going to fail, but that's fine. But you'll see that the actual generated output at the bottom is exactly what your macro does. So by leaving this empty, you're basically saying, don't worry about the diff. I thought I said, yeah, thanks. Okay, that's really helpful. Even though do not disturb is on, it's still doing that. Anyway. Thanks, team. Yeah, so by leaving the whole point of the assertion is that you're comparing the generated code with what you expect to see. But if you leave it empty, then you get a nice, clean diff output of the actual code that I wrote, and then what I'm expecting the macro to do, effectively. So let's walk through this quickly. The other one as well is really helpful to, if I go into mockable macro, so inside your standard macro expansion, first thing I always do, because I've got no clue how I can look at this code and know what the hell that actually means, what that actually translates to in Swift syntax. First line is always to dump the declaration. And I just leave that there constantly throughout the whole thing. So then when we actually run that again, if I expand this up, you'll see that this 3 lines of code translates into this syntax tree. And then when you actually go to try and parse the syntax tree, you've got the syntax tree right there. There's also a website called SwiftAST Explorer, I think, .com. That's actually very helpful. I find this is a bit quicker because it's a quicker iteration time and I'm not waiting for a website. Plus, if I'm doing work stuff, I'm pretty sure my boss would be very unhappy with me posting work code into a foreign website. So this stays in Xcode. Right, so the other part that I put onto this is I just have an empty one that I can use to go the other way. So if I'm trying to Actually, I'll come back to that. But if I'm trying to, you write out the source code you're expecting to see, look at the syntax tree, and then you can actually reverse it that way. But I'll get to an example of that. Okay, so the first thing, first tip is dump everything. Dump repeatedly, write it out, try it, read it, because Swift is actually really bloody complicated. So if I do a function with a couple of args, and the good thing about SwiftSyntax is this doesn't actually need to compile, it just needs to be readable. Save that, run that. Don't you dare. So we see now the syntax tree is a lot bigger. But it's not more complicated. So there's got the macro itself, attribute list syntax, symbol type. So that's the macro declaration. The actual protocol keyword, it's got a public modifier on it. It's called service, and it's got some stuff inside it. The stuff inside it is a member declaration with a list inside that, which has a function declared. And you can see it as you go through. There's actually more errors. Oh, I got some syntax errors in that. What did I do wrong? No, that looks right to me. Where's the protocol? It shouldn't have a return value. Doesn't need to have a return value. But anyway, you can see it's passed it anyway. And what I wanted to get to is this bit here. So this here, inside the function signature, is a function parameter list syntax. Cool. It's got a function parameter, two function parameters, one called arg1, one called arg2, with some types. Pretty straightforward. But if I were to then do, instead, go a type alias and do exactly the same, I'll copy and paste so there's no way I can get it wrong. And return void. So same thing, it's a closure instead of a function. Signature's the same. Let's see if we can actually figure out what went wrong with that. So I didn't change the other one, now it's fine. Anyway, oh no, there is an error there. Oh, I know what that was. I was testing something else, but they've got a better error there now. Cool, that's good to see. Okay, so we've got, where are we? Do thing, here we go. Type alias declaration. The type alias keyword at the start, it's called do thing. But this time, instead of being, what was it? A function parameter list syntax, it's now a tuple type element list syntax. So this exact bit of code that I copied and pasted, because it appears somewhere different, has an entirely different structure. And mapping between those two can get really complicated. And has tripped me up so many times. Generally, when you're trying to write SwiftSyntax, as long as you're using the builder stuff, you can't get it wrong too much. But trying to parse it is just a gigantic headache. So that error that came through, the reason that's there is because I was testing this before. Did I actually break it? Lock function. In the initializer, something, something. This one. No, it looks right. All right, so if I go back to this. So this is where understanding the basic building blocks of Swift, the difference between a declaration, an expression, and a statement, actually is really important to SwiftSyntax. To you and I, they're all the same, right? I can never remember the difference between a expression and a statement. I'm pretty sure one's a subset of another, but I always get it around the wrong way. But if I go down here to the actual generated code, so this line here, so what this macro does is it takes that function declaration, creates a type alias for it with the handler function, sets it as a variable. So it's generating a mock class basically. So you can pass in a closure. Your closure is called whenever the function is called. We create an initializer with an optional one on it, and then we set that value. So this line here, it comes from, not that function, this function here. So I've made a function called make initializer assignment. I'm returning an array of expressions, and you can see that it's self.property name equals property name, which is exactly the same because I'm using the property name as the variable in the initializer. Now this is an expression. So what happens if I change that? So if I change that to a statement, and then I rerun it again, such a small code window. So rerun that again, you'll see that it's not worked. Great, what have I done? Oh, I took the thing out. When did I do that? Put that back. Okay, so it hasn't errored, but you'll see that for some reason it's on, it's up here. For some reason it's now on the same line as the last declaration or as the last statement. It hasn't put the new line in there, there's no semicolon, that's a compiler error. But it's not a compiler error on the SwiftSyntax macro generation side, it's a compiler error in the generated code that you then have to try dig in and go, well, what the hell does that mean? Which you hope Xcode's playing nice, but sometimes it's not. So getting those right is important. And I've seen it do some really weird stuff like put extra spaces around quotes and stuff like that. Like, so if you see the code looks wrong, you've probably got a declaration statement or an expression mixed up somewhere there. Couple of last things. It's easy to go off the examples that Apple provides and try to put everything into your macro declaration. I've actually found it's a whole lot easier to remember that we are in Swift. We can use types and classes, and if you're going to generate a bunch of things that are related, put it into a type with an initializer that has properties. So if I'm generating some function stuff, I've popped this in here. The passing function's in there as well, but I just generalize it down, right? This is the original declaration, and these are the bits that I'm generating off the back of it, so that when it comes time to actually make the function, to actually print the function body as a code block syntax with all the code inside it, this is a lot easier to read, especially if you put examples of what you're expecting it to look like in the doc blocks, than it is if you try and do it all in as spaghetti code in the other one, which is what Apple's kind of examples tend to lead you towards. But you definitely don't have to do that. Last three bits. You really, as it's generated code, you probably don't need to care too much about the white space and the trivia, as SwiftSyntax calls it. But you know, some people do. Sometimes it's actually important. There is a really cool thing called, let me find somewhere I can do this. Here, XPR syntax, right? There is, if you ever need to actually take something that it's either passed itself or you're moving code from one spot to another and transforming it, there is a handy property called trimmed, which will return the declared element without all the white space and without all the other garbage, meaning that if you then use that where you're outputting your code, you're not going to get bonus tabs or spaces that were in front of it, or extra bonus new lines and stuff like that. It's going to make it a lot easier to debug where things are going wrong as well. So trimmed is very important. Oh, okay. Last two. You saw in this bit that we can see all of this stuff inside the declaration that we've attached to. But you cannot see or understand anything about the code that comes in. So you can see I've got this something else property, which we assume is a type, but we know nothing at all about that type. All we know is that it has an identifier, which is a string called something else. That's all we know. We don't know what it is. It's a type alias for strings. We don't know what it conforms to. We have no context as to what that is. So it's equally important if we were to put, an extension on this. So let's say we made this. I don't know why I'm making it nice, because it doesn't really care. Right, and we put an extension on that. I don't know. Where other type is string, and we did some stuff here with the default implementation, blah blah blah. If you actually build that, on the declaration itself, oh no, that's the full tree. The declaration itself has no mention of the extension. It's only the declaration that you can see, and it's only what's inside this code block that you can work with, which makes the last point I want to talk about, generics. Generics are basically impossible with the amount of information we get given to infer anything at all about a generic other than the fact that it's a generic. So you might think with our nice, what am I going to call this? Thing type, whatever. As Swift programmers, we would think where in code these two are equivalent. Like when Xcode gives it to us, we know that other type will be inherited from thing type. That's something we know as engineers. That's something that Xcode will give to us. In SwiftSyntax, I don't know where that problem's gone. Anyway, in SwiftSyntax, here we go. They're different, right? So this one is associated type, other type, generic requirement list, generic requirement syntax, a conformance syntax, and it conforms. So this type, other type, conforms to this type. Cool, straightforward. The other one, let me bring that back up there, is now a parameter clause syntax, a function parameter list syntax. No, I've gone too far. Here, it has, the associated type, other type. It has a where clause after it, and then the where clause says that, this part is the same, but it's located in two very different places. So if you wanted to try and actually do something with that generic, if you wanted to try and actually make it possible, so let's say, and it's exactly the same on function arguments, right? So this is, so if I would then do this, this would have been a better example to begin with. Right? These are equivalent, but in SwiftSyntax they're very different. So if you then try to do something with that, you need to first of all consolidate down your generic lists from multiple places, try and collect the conformances from multiple places just to get to a list that says other type conforms to this, and then you hope that you have it all. You can do that, it's just painful, hugely painful, to end up with basically the same thing, right? Because you can't use a generic in a type alias, we have to abstract the generic out, figure out if we can conform it to anything, figure out if it conforms to multiple things. Like, that's one thing. What if I then go other type, other thing? Now you've got two, so now you've got to squash the generics together, turn them into an ampersand function. I didn't fix that, and that's where the other thing is going wrong too. That's where that error is coming from. Cool. But yeah, you can see you can do that, but it's a lot of effort to unpack generics and to gather their conformances, so it's a lot more work than you might think. That was everything I wanted to talk to. Were there any questions? Sure.
How do you decide what you're going to use macros for and what you're not going to use macros for?
I've tried to use macros for 6 things now, and I've been successful in 3. So there's the first one, I wanted to replace a property wrapper. I've actually wanted to replace a couple of property wrappers with a macro. Once I was successful, once I wasn't, because the first one, can I do this on here quickly enough? We'll see. So the first one relied on outside conformances, and it uses that. You can't see that inside the macro because it's outside the declaration. So you could do the macro work, but the error that it's going to give back to the user if they misuse the macro is unintelligible. They won't know how to fix it because it's going to be a standard Xcode parser error. Whereas with the property wrapper, it will tell you that you're missing a conformance to a protocol. So that was the first one. Some of the other ones have been more successful. This one seems to be working, though I'm still trying to deal with associated types and a couple of other fun things that I haven't quite nutted out properly yet. closures inside inside function declarations are also fun. But this one has taught me a whole lot of edge cases that I never would have considered before. So it's been a really great introduction to that. Basically, the advice is try it and find out. Worst that happens is you waste a few hours, or maybe several days like I did. That's all right.
So it seems there's a balance here between obfuscation and convenience. And what do you land on that? Do you think this is mostly for library code? Yeah,
I think so. I'm mainly using it for two things. One is to automate generation of boilerplate. That's the main one, or to remove boilerplate, stuff that you repeat often. Again, you can't. This one is okay because I can use a peer macro to add boilerplate alongside the declaration. But if you were trying to do that in different files, for example, to generate like this is a test helper, but it has to live in the main code, so I have to if debug it, and I have to put an assertion in there to make sure it can't accidentally be used inside real code. So there's a whole bunch of workarounds like that. Ideally, I'd like to declare the macro in a test target, but you can't do that because it's in a separate file and you can't see that. So yeah, you can do boilerplate's the main one. The other one is to replace the use of mirroring, which you could do with boilerplate to generate a walker or a visitor type thing, and that's what I'm doing now. So boilerplate's the main one.